Good morning, students. So in our last class from the exercise 6.5, from the question number 1, we have done 2 questions. So the remaining question today we have to do. And here the question number 3 is given. As you see, the question is mentioned here, find the maximum and minimum values if any of the following functions given by. So the third question is given, fx equals to minus x minus 1 whole square plus of 10. And the fourth question is here given, gx equals to x cube plus 1. So now the first of all, here we have to do the question number 3. As you know, already we have done this first 2 questions. The same process here we have to apply. And the third question is here, minus x minus 1 whole square plus 10. So clearly it is visible here. If you accept this minus sign, then here x minus 1 whole square. Whole square means what? Always a positive value. So that's why here we write, it can be observed that x minus 1 whole square is always greater than equals to 0, because whole square term given. So it may be 0 or more than 0. So that's why greater than equals to. But in our function here we need minus x minus 1 whole square. For that reason here we have to multiply both sides by minus. So in case of inequation or inequalities, we know when we multiply both sides by minus, the sign will be automatically changed. For that reason here the sign will be changed. And if you see here one example also written, you see 7 is greater than 5. If you multiply both sides by minus, here minus 7 minus 5, which one is greater now? So obviously minus 5. So sign will be changed here. So that's why here when we multiply both sides by minus, then the sign will be changed here. Is it clear? After that, to balance this result we need plus 10. So that's why adding both sides by 10. So when we add both sides by 10, the left hand side part is here minus x minus 1 whole square plus 10. So in place of this, what we can write? Fx. As you know, in this question given. So in place of this one, if we write fx, so fx is less than equals to 10. If fx is less than equals to 10, so what is the meaning of this one? So that means the fx value is not more than 10. Here the meaning of this one is fx is less than equals to 10 means here the maximum fx value is 10. So that means here we get maximum value. For that reason here we write the next line. If you see here we write the maximum value of f is attained when we get this value, when this x minus 1 value is 0. So that's why here we write x minus 1 value is 0 equals to 0. Then from here we get x equal to 1. So if this x minus 1 value is 0, that means this part is 0, then we get the maximum value. Maximum value is 10. So that's why from here if we find out the value of x, x equal to 1. So now if we put this value x equal to 1 on this given function, 1 minus 1 0. So that's why here you see written the calculation here done, and this one is maximum value of f equal to f of 1, and if we calculate this result, finally we get the answer is 10. So from here what we can say? Finally we can say here hence function here function f does not have a minimum value. Is it clear? The function whatever given f here does not have a minimum value, because here the maximum value is 10. Is it clear? Okay. Now here similarly another one question is given here, which one is gx equals to x cube plus 1. X cube plus 1 given here. You see. So now in this case x cube is a odd function. So in place of x, if we consider x is a real number, x may be positive value or x may be negative value. So if positive, then we get a positive result. If x is negative, then we get a negative result. So we can't say here anything. whether it is positive or negative, or whether it is greater than or less than. Only for that reason, here what we have to write, our conclusion is function g neither has a maximum nor minimum value, because we can't predict x cube is a positive value or a negative value. Only for that reason, here our answer is what? Neither maximum nor minimum. Is it clear? So that means if odd function given, so our answer is neither maximum nor minimum. So in this way we have done here the first 4 questions from the question number 1, exercise 6.5. Is it clear? So now next, the question number 2. So if you see the question number 2, the question number 2 is given again, find the maximum and minimum values, if any, of the following functions given by. So the question is same. So without using derivative, again we have to find out maximum and minimum. But in this case, the functions are not given polynomial. In this case, the functions are given here. The first question is given modulus function. So here question is given fx equals to modulus of x plus 2 minus 1. So modulus of x plus 2 minus 1 here given. So that means this one is a modulus function. So in this case, without using derivative, how can we solve? Now first of all, we have to write function fx equal to, we write modulus of x plus 2 minus 1. Now here, from here we can observe that here, or we can write here, we know that this modulus part is never negative. So that's why here we write, we know that modulus of x plus 2 is greater than equals to 0. That means the meaning is what? The modulus value may be positive or may be 0, but not negative, not less than 0. So that's why here modulus of x plus 2 is greater than equals to 0. If it is greater than equals to 0, to balance this result, to get this function, what we need? With this we need minus 1. So adding both sides by minus 1. One thing you remember, when we multiply by minus, then the sign will be changed. Otherwise we add or subtract, then the sign will remain same. So that's why here x plus 2 already there. So we just add minus 1 on left hand side and right hand side. The sign will be remain same. And now here when we write x plus 2 minus 1, why we write minus 1? To get this function, to balance this result. So that's why we add minus 1. So now here modulus of x plus 2 minus 1. In place of this one, what we can write? We can write fx. So fx is greater than equals to minus 1. Is it clear? So now here we get fx equals to greater than minus 1. So what is the meaning of this one? Fx is greater than equals to minus 1. So fx equals to greater than equals minus 1 means the minimum value of fx is minus 1. Isn't not it? So the minimum value of fx is here minus 1. So for that reason, here we write the minimum values of f is attained when we get this minimum value, when the modulus part is equal to 0. So that's why modulus part is what? X plus 2 equals to 0. So x plus 2 equals to 0. And from here easily we can write x equal to minus 2. Isn't not it? So x equals to minus 2. So therefore, how easily we can write down the minimum value here? Minimum value of f. This one we write f equal to minus 2. And in place of x, we write minus 2. So that's why here we write modulus of minus 2 plus 2 minus 1. So if we calculate this one, then finally we get minus 1. And now here, finally the conclusion, what you have to write? Hence, function f does not have a maximum value, because here already we get this one. If you see here, the minimum value is minus 1, because fx value is greater than equals to minus 1. That means what is the meaning of this one? The minimum value of fx is minus 1, but the maximum value we can't predict, because here greater than minus 1, that means lots of values are there. So that's why maximum value we can't write. So here for that reason the minimum value is minus 1, and hence finally we write function f does not have a maximum value. Is it clear? So today we have done the first question from the question number 2. Isn't it? So some more questions are here in under this question number 2. Some modulus questions are there. So in our next class, we have to continue these questions. That means the exercise 6.5. So you have to copy these questions, and if any queries or any questions are there, you can ask me in my WhatsApp. Is it clear? Okay. Thank you.